first say you're going to design a crank, you have to think at the beginning, but it's not a crank. You just have to think this is just two arms linked to a shaft. It was back in 2009. I think the idea came when we were playing about with the 934 cassette. We thought it would be nice to have a crank to go along with it. But where we played a lot, it's all with the arm to the shaft connection. We probably have 5 variations of them, using splines or no splines, splits, no splits, all sorts of different ones. For your chainring, you know, we started playing around with different PCD. We thought about the, like on the old disc we had ages ago, back in the 90s. It was just attached onto the hub with a lock ring. So we thought we could do the same for the Spider. Like every project like this, when you first look at it, you think it's easy, but it's never easy. Nothing is ever easy.
My name's Lynley Pate. I'm the Works and Production Manager. We've gone down the forging route because it is a lot stronger. During the forging process, the grain structure, it's sort of mashed around into various directions, and that just gives you a lot stronger part. You know, we realised we couldn't actually produce these without buying a new machine. We couldn't physically fit them into the schedule. So we brought in this new 4-axis horizontal. And I was saying earlier, it's not just to produce cranks, it's to produce a range of other parts further down the line, which will increase capacity. The working envelope for the machine is quite large, and so on one tombstone we can get 16 crank arms. But we have the machine itself will hold 15 tombstones. In this particular case, there's actually 3 operations on 2 different machines. So in total, there's 20 cutters used. The machine itself is capable of running the cutters at 15,000 RPM, but we run them about 13,000 RPM. So it's quite fast, high-speed machine. It's about 24 minutes per side. So the drive side is about, I think the drive side is about 25 minutes, the non-drive is about 23 minutes, so you've averaged 24 minutes per crank arm.
The spindle's made out of bar, 7075 aluminium, and then eventually they'll be done on twin spindle machine and finished in one operation, but at the minute they're multi-ops, and this is just doing the final op, which is finishing the bearing diameters and putting the 32 spline on.
So once you've programmed it to produce a certain shape, it will repeat that shape within 1 micron, which is 1,000th of a millimetre. So it's a very, very accurate machine.
We were thinking single ring, so we were like, what, 30? And then so we were going, oh, we'll make it 30. And then say, oh no, but maybe someone with like the bigger wheels, they want lower gears. So wow, it's got to be 28, so we're changing that again. But then we thought, well, someone will still want to run double ring, but that was two different crank arms already. Now we've got only one, and you can fit one Spider and takes a single ring, or double ring, or spiderless chainring. It's a lot more versatile.
Hi, I'm Crampy, and I'm an R&D machinist and test lab operator. Started off with pinch bolts, found that they were an extreme weak point on it, to be honest, so we moved away from that, and now it's all encapsulated. There's no pinch bolts to pull away, can't shear them off, and it's resulted in a much stronger crank. We start off static loading on this machine. We basically apply a set force, measure the distance it moves it. This way we can test different prototypes, different designs of prototypes, to find out which are stiffer. Obviously the stiffer the crank the better. Any material has got an elastic limit where ideally when you put a force on something the graph will climb sharply up, and as soon as it starts to taper off that means you've reached your elastic limit and that's beyond its usability. And then from there we move on with that information onto the fatigue machine, which applies 50,000 cycles at 1800 Newton meters on one pedal arm. This simulates a rider riding downhill, and this way you can basically simulate a year's riding in 12 hours. So yeah, it's pretty real world testing. So we have the other machine which holds the cranks at 45 degrees and puts 1800 Newton meters on one pedal arm and then the other pedal arm, and it does that for 100,000 cycles, and that simulates a rider pedalling. A lot of our tests on these machines they're not for EN standards. They're for us to test that our products are strong enough in our mind.
Periodically through the machining process, the cranks are taken into the inspection room. They are placed on a CMM coordinate measuring machine.
So what they do, you get a drawing from SolidWorks. When the drawing comes in, it's a 3D model we get from there, and if we import that software, the drawing's into the software, and actually will give all the points they have to measure. The operator tells it which points it wants to inspect, and use different size probes depending on what size the feature is on the part. It'll go around those parts and confirm dimensions. Measures to be about, it's 0.001 of a millimetre, so 1 micron. So that goes around all the parts and it confirms whether it's right or wrong, and we can adjust the machines afterwards to correct any errors that will be in the machining.
'Crank arms are brought into anodising from the polishing and cleaning department. They're then jigged up on the appropriate jigs, ready for anodising. Start off the process by dipping them into the cleaning tank for 5 minutes. That cleans any fingerprints that's maybe on the component. And then after 5 minutes in the cleaning tank, they're then rinsed off, so there's no cleaner left on the component whatsoever. Then ready for anodising in the anodising tank. "20 minutes in the black dye, which is at a 50-degree centigrade temperature. Once they come out the black dye, they're then rinsed off again completely, and then the sealing process begins. The sealing process takes about 20 minutes. It's cold seal, room temperature, that locks the dye in completely.
I think it's made us it's sort of instantly and recognisable in the market, isn't it? Is not only the logo but the actual features and the lines and everything, the graphics. It really does stand out from the competition.